Hello. In this video we're going to be factoring, and specifically we're going to be factoring expressions that have a leading coefficient that is not equal to 1. So in general, if we have a trinomial that is ax squared plus bx plus c, as our most general example of something that we might want to be factoring with this technique, in general a could be anything. It's oftentimes easier if a is 1, but we're going to consider the case where a is not equal to 1. So what's our goal in factoring? Our goal is to turn this into something that looks like two binomials multiplied together. So maybe dx plus m and fx plus n, perhaps. So we take something that is 3 terms and turn it into multiplication of 2 binomials. Well, how can we do this? We can look to see what sorts of restrictions we have based upon the correspondence between these two things, right? If I multiply dx times f of x, that has to equal ax squared. And in particular, that means that d and f have to multiply together to equal a. Similarly, we can look at m and n. If I multiply m and n together, that's the constant term over here, right? So m times n has to be equal to c. Well, what this means is that if we write out the factors of a and c, then we can see what the candidates for d and f and m and n are. And then we can check through and eliminate the possibilities. So let's do an example with some numbers. In particular, we're going to do negative 4x squared minus 21x minus 5. So let's factor this trinomial. Well, what we can do is we can say, well, what are the possible factors here? We might have 1 and 4, and maybe plus or minus, plus or minus. Maybe we'd have plus or minus 2, plus or minus 2. 2 times 2 equals 4. 1 times 4 equals 4 as well. And what are the possible factors of negative 5? Well, here we'd probably have plus or minus 1 and plus or minus 5, right? 1 times 5 gives me 5. And then we would have either plus or minus to make sure that our overall minus sign was satisfied. Well, looking at this, we need to figure out, well, what are those possibilities? In particular, we need something that is going to get us this minus 21 in the middle. So how do we get to minus 21? Well, we get to minus 21 by looking at the cross terms. So if I take something like 5 times 4, that'll get me to 20, and that looks like that'll get me most of the way to this minus 21. So we can do this by looking and saying, well, what if I try something like this? Maybe minus 4x and 5. That gets me minus 20x. Well, if I have minus 20x, I'm almost all the way to minus 21. What I would need is I'd need something like maybe minus 1 times x, because minus 1 times x, that gives me another minus 1. Minus 20 minus 1 would give me minus 21. And we can also check to make sure that all the other pieces are satisfied, right? Minus 4x times x gives me minus 4x squared. Minus 1 times plus 5 gives me minus 5. And then we know minus 20 minus 1 gives us minus 21. So this here is equal to this expression of the 2 binomials, which is great. We should always ask ourselves the question, can I factor any more? And it looks like I have a greatest common factor here, which I potentially could have taken out right at the beginning. Which, that's fine if you see it at the beginning or you see it at the end. It does not matter. You will still end up at the same place. So let's take that minus 1 out. I have minus times the quantity 4x plus 1 times x plus 5. And so this would be where I would end up with my completely factored expression, minus times the quantity 4x plus 1 times x plus 5.